senior architect for fourTheorem, and an AWS Serverless Hero, author and speaker. Well, that's a good thing because he's here on the show. The topic is your Lambdas in Rust. All right, he's currently a senior architect where he's helping companies to get the best of cloud, AWS and serverless. He loves full stack web, Node.js, and serverless. Wow, we just had a serverless. We're talking serverless. We're talking Rust. Man, this is pretty cool. And did you know that Luciano is an AWS Serverless Hero who was born in 1987, the same year Super Mario Brothers was released in Europe, which by chance is his favorite game. Luciano, thank you for joining us. I have a question right away.
Go for it.
Are you still playing Super Mario Brothers?
Not as much as I want because, I need to work sometimes, but I do, yeah.
Work's overrated. All right, Luciano, I'm going to leave it to you. Thank you. And that is an awesome slide.
Thank you so much, John. All right, so I guess you can see the slides. So I'm going to go on and start with the introduction. So actually, before I do that, I already have the slides available online, and you can just get them by either scanning the QR code. Sorry, no prizes, but you can get the slides. You can go on the link there in the chat. And while you do that, I can just introduce myself. So again, I am Luciano. You can guess my nationality. You already know that I am a serverless hero, senior architect of fourTheorem. And when John mentioned that I'm an author, not related to AWS or Rust, related to Node.js, but if you are into that kind of things, you can check out the book and let me know if you like it. And definitely feel free to connect with me. You can find me online in most places, and definitely connect. I'd be happy to keep chatting with you after the event. And I'm going to drop my link tree here as well, because that has more links as well. Okay, so let me tell you very quickly something about fourTheorem, the company that I work for. We are a consulting company specialized on AWS. Some of the things we do is helping companies to do cloud migration, so go from on-premise to the cloud. We do training and cloud enablement. We build high-performance serverless applications, and we are also helping some of our customers to cut down cloud costs. If all of that or some of that sounds interesting to you, reach out to me or reach out to the links you see there in the screen. And just one last thing I want to mention, and then I'm going to stop the shameless promotion, is that we also run a weekly podcast about AWS. Some of the episodes are quite funny, like this one. So if you like podcasts, you like AWS, please check it out and give us some feedback, because we'd love to do more of this kind of things. Okay, so let's get into the talk. So Daniel already gave a very good introduction about Lambda, so I'm just going to remark some of the use cases that I think AWS Lambda is particularly suitable for. HTTP requests, you can easily build APIs with Lambda. So you use API Gateway and Lambda on the backend. You can basically create workflows where if you drop a file in S3, the file storage, you can do some kind of computation and process the files in real time. You can run jobs off from a queue and compute them using Lambda. You can orchestrate different things using step function and using Lambda as the kind of business logic to orchestrate the step function. Or you can even just run things on a schedule. Maybe you want to crawl a specific website every day, fetch some information from there. You can just schedule a Lambda to do that every day. So Lambda is just a great tool for us to do event-driven computation, as already was said by Daniel, and I totally agree with that. Okay, but do you know about Lambda pricing? Some people know, some people don't. So I'm going to try to summarize what is the formula to come up with how much it's going to cost me to run something on Lambda. And the formula is actually very simple. It's based on the amount of memory that you allocate for your Lambda and for how much time are you actually running a specific Lambda in milliseconds. So let me just give you an example. If you take 112 megabytes of memory for a given Lambda, in a specific region, I think this was Ireland region, this is going to be the cost of that amount of RAM per millisecond. So let's just say that you run that kind of Lambda for 15 minutes. You basically have to calculate this, and you're going to end up with $0.007. Sorry, this is a terrible joke, I know. But yeah, the point is that it's going to cost you less than 1 cent of a dollar to run a Lambda for pretty much 15 minutes. So that just gives you an idea that what is the cost for Lambda. Now, this seems very cheap, but keep in mind that you might be running thousands of Lambdas per second. So if you are running those thousands of Lambdas for 15 minutes, you already have to multiply that number by 1,000. So you can imagine how this can escalate very quickly. So it's always worth to keep in mind that it looks very cheap if you look at alone, like this standalone single execution, but you have to think big and you have to think at scale sometimes. So it's important to do all your own spreadsheet and make sure you understand what are the cost implications of your architecture decisions. Now, one thing that I didn't mention is, what about CPU? We only spoke about memory and time. What if I need CPU? What if I want to configure CPU? And really interesting in Lambda is basically you don't get to choose the CPU. It depends on the amount of memory that you select. You will get a different amount of virtual CPU. So just keep that in mind, because sometimes you just need more CPU for specific workloads. And that means that you need to increase the amount of memory, but also that means that you are going to be increasing the cost of running that particular Lambda just because you are allocating more memory. Now, how do we write a Lambda? I already told you that I like Node.js. So spoiler, you get to see how to write a Lambda in Node.js first. And it's very simple. Lambda, we said it's function as a service. So we have to write only a function. And when it comes to Node.js, the function has a very specific signature. So it's a function that can be asynchronous because we can be doing different I/O processing inside the Lambda code. And it takes an event and a context. And just to see an example, generally what we do is we need to read something from the event, which is going to be our input. We run some kind of business logic, and then we return a result. And in this particular example, what I'm doing, imagine we are implementing like a kind of a status checking for an HTTP endpoint. What we do is we actually get the URL from the event. So this Lambda can process different URLs. Then we actually ping that URL with an HTTP request. In this case, I'm using fetch, and then we return the status code. So with this Lambda, we can check, for instance, if a specific URL is giving us a 200, which means everything is fine, or maybe we are getting a 404, so probably there is something wrong with that URL, or even worse, we're getting a 500, so there is an actual error. So you can use this Lambda that way. Now, if you look at all the languages that are supported in Lambda, those are also called runtimes. You will see Node.js, you will also see Python, Java, .NET, Go, Ruby, and you can also see the custom runtime. But this talk is about writing Lambdas in Rust. So you might be wondering, where is Rust, right? It's not there. So that's a bit of a problem. But actually, the interesting thing is that there is a solution for that. We can write our own custom Lambda using a custom runtime and use Rust for that. And actually, we don't have to start from scratch. We don't have to really understand how to write a custom runtime, because AWS itself is giving us an open source runtime that is already built to run Rust code. So I'm going to be showing you actually how to use that. There is a little bit more boilerplate, but the code is not too different from what we saw before in Node.js. And the idea is that here, what we need to do is that we still define a function, and this function receives an event as well, and it returns a specific result. And then we have a little bit of extra code here where we are basically saying there is a main function. So imagine that this is just a binary that gets executed at some point inside AWS. And this binary needs to bootstrap that function, which is our actual Lambda handler. So we just need to write this little bit of extra code every time we want to use this custom Lambda runtime for Rust. Now, the next question is, why do we bother about Rust though? Like, yeah, there is a bit more work. I could just use Node.js and keep my life simple, but I want to use Rust. Okay, what is the advantage in doing that? And of course, this is an opinion, but you can take it or not. But I'm going to try to explain why I think Rust can be a good choice for Lambdas. And let's talk first about Rust as a language, and let's try to understand what are the trade-offs that the language brings to the table. It's a relatively new language, has been around since 2015. It is a compiled language, so it is a little bit different from languages like Python or JavaScript, Node.js, where it is interpreted. It focuses a lot more on performance and memory safety. So if you have cases where performance or memory safety are important, that's a strong point in favor of Rust, but also provides high-level constructs. So you might think that lower-level languages traditionally are things like C or C++ that are generally low-level, like you really need to build a lot of stuff yourself. Rust is kind of a trade-off there where It is low level if you want to, but there are also a lot of high level constructs that you can use straight away. And one example of that is, for instance, iterators. And in general, it positions itself as a general purpose language. So you can use it for system related things, like you could build your own operating system with it, but you can just build your own Lambda or your own web framework or web server with Rust. So it's that kind of language that gives you a lot of flexibility. And another thing that I really like is that because it's a relatively modern language, they took the best from modern tool chains. So you get a package manager, you get a lot of things that you would expect today from a modern language. And the best part is that there is a great mascot. I don't know if everyone agrees because the survey there wasn't really satisfying, but I really like it. Okay, speaking of the package manager, there is actually a built-in package manager, which is called Cargo. And it's kind of, if you are used to Node.js, it's like NPM. If you're used to Python, it's like pip. So basically, you can use it to download packages from the internet every time that there is something that you need, but that something is not available in the standard library. But it's also more powerful than that because you can use it also for scaffolding a new project. You can decide whether you are creating a binary or a library, and it's going to give you some starting code, and it's going to structure already your project in the right way. It's going to help you to run your own tests, and you can even extend it with custom commands that will do certain things that are very specific to the domain you are working with. And let's try now to tie it back into Lambda. Why Rust with Lambda? And the main thing to me is that Rust is considered a very performant language. And if you combine that with memory constraints, because it's a compiled language, so it produces very memory efficient binaries, these are the two dimensions that you are going to be paying for when it comes to Lambda. So if you get great performance and great memory efficiency, that means that your Lambdas are going to be much cheaper just by the fact that you are writing them in Rust. Also, if you're creating multi-threaded Lambdas, the language itself prevents a lot of the common mistakes that you will do while writing multi-threaded code. So that's another reason to pick Rust if you are in that particular case. Another thing that I really like is that the language doesn't have null types and also provides very interesting ways of dealing with errors. And I think the two things combined will help you to reduce the number of bugs, just because certain things are very explicit. So you have to decide exactly how to handle, for instance, the absence of certain values, or cases where there can be an error. You are kind of forced to think about what am I going to do if that case actually happens? And that is going to result in fewer bugs in your code. Now, I'm going to go very quickly. How do you start creating your first Lambda in Rust? We already spoke about the custom runtime that you can use just by using the open source version you get from AWS. But there is another tool that is also built by AWS, which is called Cargo Lambda. And this is an extension of Cargo, the package manager. And what it does, it basically gives you a bunch of commands, for instance, Cargo Lambda new, which is going to scaffold an entire project that is already prepared, containing all the boilerplate that you need to basically write a Lambda and ship it to AWS. You just need to add your own business logic. Then you can use Cargo Lambda Watch, which is going to keep watching your code and building in the background. So as soon as you do a change, you're going to see that change already available in your binary. And it also gives you an emulator, so you can test your changes straight away. You can use Cargo Lambda Invoked to test it locally against a very specific event that you want to test. Build to build the final package, like the zip that you have to send to AWS. And finally, Cargo Lambda Deploy to actually publish this binary. Now, there is another tool that I'm going to show very quickly because Daniel already gave you some insights on that, which is called SAM. And this is just the idea that you should be doing infrastructure as code, in my opinion. And SAM is a great way to do that if you're building serverless applications. And Daniel already showed you how to do that, but just as a reminder, you will be writing some kind of YAML like this. And the idea is that you define your Lambda, you define your policies, you define if you're using other resources like DynamoDB tables or buckets. And in this declarative way, you can tie everything together. And then you take this and just ship it to AWS. And AWS will be responsible for reproducing all that you described into your own cloud environment. Now, the good news, this is what I want to add on top of SAM, is that you can use SAM and Cargo Lambda together. So SAM is used to define all your infrastructure, while Cargo Lambda allows you to build and test your own Rust Lambda code locally. And I don't have too much time to just give you a full example, but I have this link here, which is a project that I built for my own fun, just to learn more about this stuff. And it's something that basically allows you to, it's a little application that allows you to monitor for earthquakes. I am originally from Sicily, which is an area that has a lot of earthquakes. And I use this tool that I deployed and built with Lambda and Rust to monitor if there is an earthquake close to my family. I'm just going to get an email straight away so I can just get in touch with them and see if everything is all right. So if you're curious about this, you can check out the code and see how you will build Lambda in Rust and deploy it to AWS. And just as a summary, I think serverless is a great way to build applications. Rust is a great language and has a great ecosystem to build all kinds of applications. So serverless plus Rust, I think it's a great combination. And you can use SAM and Cargo Lambda to get that good developer experience so that you don't have to start from scratch. You don't have to figure out how to do all the boilerplate and how to deploy all these things to AWS. So that's everything I have for today. Again, there is a link to the slides if you want to click around and review some of the links that I shared. But yeah, that's all I have. And feel free to drop questions and ask stuff.
I'm waiting for it to respond. My camera comes on. There we go. It was a little slow today. Actually, I have a poll question that you put in there, and just because of the mascot that you put there, Luciano, this is actually pretty cool. How cool is the Rust mascot? Do you like the mascot? Is it a crab, or it's crab, or it's not crab? It's crabby. I'm not sure. Wait, do programming languages have mascots? I wonder how many don't have a mascot. Okay. So the poll is still open and it is changing, but everybody, 48% of you, 50, 51, 61. Wow, you guys, I love how it's live and does this. You really like the mascot. It's crab, 22%, followed up by, wait, do programming language. So about half of you either don't like it or don't know if it has a mascot. That's pretty good. But Luciano, I know you do like the mascot. Before we get to your questions, everybody give Luciano hands down, like hands up, thumbs, high five, a wow for his presentation. Yes. Luciano, let's talk about Rust. I know you said it hasn't been around a while, but when you say 2015, technically 8 years in IT is like 30 years, to be honest with you. Is Rust hard to learn, and how did you learn it?
Yeah, that's a great question. I think it is a little bit hard to learn, at least compared to other programming languages, or maybe that's a very personal answer just because I come from our like higher level languages like, I don't know, JavaScript, Python, and so on. And I think in Rust, you need to do a little bit of an extra effort to understand what happens when you're actually allocating memory. And Rust is very peculiar on the things you can do, because it's trying to basically give you an environment where you can do that safely. So I think learning those primitives initially is a little bit hard and frustrating. And I had this experience where I was like, wait, I'm just using this variable and doing a loop. And this is something that works in any other programming language I used before. Why Rust doesn't let me do that? So it can be a little bit frustrating at first, but eventually you learn all the kind of basis and why certain things work in that specific way. Also, you get very explicit errors. So Rust doesn't just tell you this doesn't work. It also tells you this is what you could do to make it work. And I think kind of step by step you get there. And after you are over that first kind of curve, you manage to build your own first program. I think it gets much easier from there. And then you can reap all the benefits that the language gives you.
Nice. Luciano, do me a favor, unshare your screen. I want to get you full screen so everybody can see that. I don't have for some reason, I don't have the ability to, there we go. That's awesome. So let's talk about some AWS aspects. So everybody, we're here at AWS Fest, Optimize Your AWS, Compute Edition. This is a really interesting one. We're talking serverless. Is serverless really compute for the Compute Edition? Don't answer that question. Luciano, do you expect that AWS will release a proper Rust runtime?
Yeah, that's a good question. I have a guess, but I didn't get any confirmation from AWS yet.
I highly doubt you're going to get one into reInvent, but that's just me.
Well, maybe not even a reInvent. But yeah, I am guessing that the reason why they make you build a custom runtime rather than giving you like a proper runtime is mainly, or maybe also for performance reasons, because if you have your own like standalone runtime, it means that there is kind of a network request that goes from your code to the runtime and vice versa. when instead with this approach in Rust, you are basically building one binary and everything happens in that binary, your own custom code and the runtime code. So I think that's what gives Rust the extra performance. And you get like pretty crazy cold starts. Like I've seen 8 milliseconds, and any other language is like in the order of hundreds of milliseconds, if not seconds. So that's something else that kind of contributes to the lower cost. And I think one more reason for keeping it that way, even though it's a little bit more complicated to write and deploy.
So, Luciano, I'm going to ask you one, and I'm going to ask you it in your opinion, your professional opinion. What is the best serverless deployment methodology for somebody who is starting now, CDK, SAM, serverless, framework, or any others?
Yeah, I'm going to give a shout out to Danielle for Application Composer, because I think that's another alternative that is going to come up more and more, I think, in the future, just because learning infrastructure as code is a bit scary. Like you have to write a bunch of code that doesn't make any sense. You have to look up all the properties and make sure you nest them in the right way and put them in the right place. It can be a lot at the beginning, and it's frustrating to just continuously switch between documentation, your own code, and like you don't even get a lot of feedback if you're going in the right direction. So I think that starting with Application Composer is definitely something that lowers down that initial struggle of just figuring out, am I doing the right thing or not? And it reminds me a lot of when I was using front page, like back in the days to learn HTML.
Wow, that's a throwback.
So it's kind of cool in that way that, front page maybe is not going to give you the best code ever, but it will help you a lot to create something, and then you switch to the code and understand, okay, why did they create this and that? What does it mean? So I think Application Composer, I expect, can give you the same experience, and it's going to get better and better over time. So maybe start with that. Then whichever you pick is your own choice going forward. If you prefer to write code, like actual programming code, go for CDK. If you still prefer to do something more declarative, go for Terraform or CloudFormation.
The last question is, what is the state of the Rust AWS SDK?
That's a good one. So I remember that in the last reInvent, they actually announced like the official support for the Rust SDK. Before that, there were a bunch of libraries that I think were maintained by like third-party like developers just doing it because they wanted to use Rust in AWS. I think overall it's quite good, meaning that it is quite complete. I think it gets generated together with the rest of the other SDKs. So I think you will get all the features that you get in every other SDK. The only thing that is sometimes a little bit annoying is just because it's a language where like there is a very strict type system. You have to be very explicit about how you do things, which kind of types do you use. So sometimes you have to abuse the builder pattern just to create, for instance, I don't know, a record in a DynamoDB table. You might end up writing a lot of code. When you compare that with JavaScript, it seems like you are writing too much code. But because you get also a lot of autocomplete, it's not like that big of a deal. It's just something that looks like you're writing too much code, but at the other side of it, you get a lot of help from the IDE to just make sure you're doing that right, which is not something you always get with interpreted programming languages like JavaScript. So I would say it's good. It could be better if maybe there are more helpers that can allow you to reduce that amount of boilerplate that sometimes you have to write.
Nice.